Assalamu alaikum. In this recording, I will explain worksheet 4.1. This for week 12 that you're supposed to take on a Tuesday, April 12. So the first question, a symmetric matrix is a square matrix that verify AT equal T, A equal A. So the matrix A equal the matrix AT. A matrix with a single row is called a row matrix or a row vector. So a row matrix or row vector. Also here, a matrix with a single column is called a column matrix. A matrix whose element located below the diagonal are zero is called. So since we said here below, okay, so it would be the upper triangular matrix. Okay, question number 2, choose the correct answer for the following question. Find the value of x and y that such that this matrix plus the other matrix equal 1, 7, 5, 2. So in this case, we're gonna add each element with the element that match with it. So here 2x minus 1 would equal 1. For y, I will add this element with this element and it would equal this one. So y plus 1 equal 3. By solving this linear equations, we will get that x equal 1 plus 1 over 2, which equal 1, and y equal 3 minus 1, which equal 2. So 1 and 2. The answer is B. Question number 2. The real number 7 in the matrix A correspond to. Okay, so we know that this one is A11 and this is A12 and so on. So the first number responds to the row and the second number responds to the column. Okay, so number 7 is in the third row and the second column. So the answer is C. Sorry, the answer is D. Okay. Question number 3. If A is a matrix with order 4 times 3 and B a matrix of order 3 times 4, then one of the following operation is well defined. Okay. So as you know, in the times we have to have, if the first matrix is this one, the second matrix is this one, the number of column has to match the number of row in the second one. So this is verify here. So that's why we can multiply this two matrix. But in the plus and minus, okay, we can't do that because they have to have the same order. Okay. So the answer is B. Given that A equal and B equal, perform the operation A plus 2B. So first things, we gotta find 2B. So this would be negative 2 and negative 2 and 0 and 2. Then I will add this matrix with the matrix A. So I'm gonna add each elements with the elements that belongs to. So 2 minus 2 equal 0. Then 3 with negative 2 is 1. Then negative 1 with 0, which is negative 1. Then 1 with 2 which is 3. So the answer is B. Question 5. For A equal and B equal, the order of the A times B. So for A, the order of A is 3 times 2, and the order of B is 2 times 2. So as you can see, this number is matched with this number, and we just cancel them, so we're left with 3 times 2. So the answer is 3 times 2. For A and B, find the product A, B if possible. So first, let's see if it's possible. We know that A is 2 times 2 and B is 2 times 3. Since the number of column in A match with the numbers of rows in the second matrix, so yes, we can find A times B. Now let's find A times B. First, I will take the first column, the first row in A, and I times it with the first column. Okay, so this would be 1 times 1 plus -7 times 0. Okay, then I will use the first one with the second column for the second element. So 1 times 0, then -7 times 2. Then the first also with the third column, 1 times 3 minus 7 times -1. I will repeat the same thing now with the second row. So -3 times 1 plus -7 times 0. Plus 2. Okay, so -3 times 1, 2 times 0, plus 2 times 0. So the same thing here. I will times -3 with 0, then plus 2 times 2. Then same things, -3 with 3, plus 2 times -1. Okay, now we will have, for this one, 1 times 1 is 1, but this is 0, so I'm left with 1. This is 0, so I'm left with -14. This is 3, and this is plus 1. 3 plus 1 is 4. 3 minus, this is a 3, minus plus 7 is 10. Okay. This is negative and this is 0. Also this one is 0. So -3 and 4. This is -9 minus 2, which is -11. So the answer is 1, -14, 10, 3, and -3 with 4 and -11. Okay, so the answer is A. Okay, for exercise 1, we have matrix A, B, and C. And the question is to evaluate, if possible, A plus B. Let's see. We can do A plus B since A and B has the same order, okay, which is 3 times 2, and also here 3 times 2. But the order also for C is 3 times 2. Okay, now let's add A plus B. So we're going to add 2 with 1, which is a 3. Then 1 with 1, which is 2. Then -1 with 1, 0. 3 with -1, 2. -2 with -1, -3. 0 with 0, 0. Now we will add A plus B, which we already done, with then we will minus them with C. So I'm gonna minus this one with this one. Okay, so the same thing here. 3 minus 2, 1. 2 minus 1, 1. 0 minus 1 is minus 1. 2 minus 1, so 2 plus 1, which is 3. Now negative 3 minus 2, so negative 3 plus 2, which is minus 1. And last, 0 minus 0, which is 0. Okay. Okay. So let's see. Give, if possible, AT. We know for the AT, we just have to switch the column with the row. So since here I have 1 and 2 as a row, it would be column. 2 and 1, negative 1 and 3, negative 2 and 0. So the order of AT would be 2 times 3. Okay, also for CT, we can find CT. So the CT would be 2 and 1, 1 and negative 1, negative 2 and 0. Now let's find AT plus 3CT. So AT, which is 2, negative 1, negative 2, 1, 3 and 0, plus 3 times, I'm going to times the 3 with this one, with each element of C. So this would be 6 and 3, negative 6, 3, negative 3, and 0. Now I will add them together. So the answer would be 2 plus 6, which is 8, negative 1 plus 3, which is 2, negative 2 minus 6 is negative 8. 1 plus 3 is 4, 3 minus 3, 0, and 0 plus 0 equals 0. Okay. Exercise 2. We have matrix A, and the question asks for A squared plus 5A. Okay. So to find out A squared, this means I have to times A with itself. So 1, 2, 0, and 4, I will times it with 1, 2, 0, and 4. Okay, and this would be 1 times 1, so I will take this row with this column. 1 times 1, 1, plus 2 times 0, which is 0, so the answer is 1. Then I will repeat the same things with the second column. 1 times 2, 2, and 2 times 4 is 8. So 2 plus 8 is 10. Now I will do this with the second row. 0 with 1 is 0, and 4 with 0 is 0. So 0. 0 times 2 is 0, and 4 times 4 is 16. So it is 16. This is A squared. Notice that A squared does not equal if I square each one of this, which is 1, 4, 0, 16. This is different. So if I ask you to find out A squared, you're supposed to times A with itself, not to square all the elements in the matrix. Okay, so we found A squared. Now we have to add A squared with 5 times A. You know, 5 times A is 5, 10, 0, 20. Okay, so I will find now A squared plus 5A. So I will add A squared, this one, with 5A, this one. Okay, so 1 plus 5 is 6, 10 plus 10, 20, 0 plus 0 is 0, 16 plus 20 is 36. Okay. Okay, let's see question number 3 or exercise 3. We have matrix A, matrix B, and matrix C. And the question is to find, if possible, the value of A, B, C, A, and so on. Okay, so let's first find the order of each matrix. The order of A is 3 times 2. And the order of B is 3 times 1. The order of C is 3 times 2. So can we find AB? No, we can't find AB because the number of row in A does not match with the number of column in B. So this is undefined. What about CA? So CA for C is 3 times 2 and A is 3 times 2. So the same things, this is not match, so we can't. Okay, let's see 2B times BT. Okay, for P is 1, 1, negative 1 times BT, which is 1, 1, and negative 1. So as you know, B is 3 times 1, while BT, this is B, and BT, it would be 1 times 3. So since this one match with this one, so yes, we can do the multiplication. Okay, actually we will not times B with BT, we will times 2B, so this would be 2 and negative 2. Now let's multiply this one. It would be one element. It would be, 3 times a 3 matrix. Okay, so just keep in your mind, you will have 9 elements here. 2 times 1 is 2 times 1 is 2. Okay, this is the first row with the first column. Then 2 times 1 is 2. Then 2 times negative 1 is negative 2. Now we will go to the second row. 2 times 1 is 2. Then 2. Then negative 2. Now with the third one, negative 2, negative 2, and 2. Okay. Okay. Now we have to find CT times A. Can we find CT with A? Let's see. CT would be 2 times the 3 matrix. This is CT. And A is a 3 times 2 matrix. Since the number of row over here equal the column equal the row, so yes, we can find CT times A. So CT, A, matrix CT would be 2, 1, 1, negative 1, negative 2, and 0. Matrix A is 2, 1, 1, 3, 0, and 3. Okay, to multiply this 2 matrix, we will take the first column, the first row with the first column. So 2 times 2 is 4, plus 1 times 1, which is 1, plus negative 2 with 0, which is 0. So the answer is 5. Now 2 times 1 is 2. 1 times 3 is 3. Negative 2 times 3 is negative 6. So the answer is negative 1. Okay, the same things with the second row. 1 times 2 is 2. Negative 1 with 1 is negative 1 and 0. So the answer is 1. Okay, Then the second column, 1 times 1 is 1. Negative 2 with the 3 is negative 3. And the last one is 0. So this would be negative 2. Okay. Now we want to find out this one, a plus c times b. So first we will add a with c. And as you know, if we add a with c, we will have a matrix with the same order, which is 3 times 2. Then we will multiply it with b, which is 3 times 1. So we can't multiply this 2 matrix since this 2 is not equal, it does not equal 3. So this also not defined. This one is not defined. Okay, let's see b, a plus c. Okay, so b, a plus c. A plus c have the same order of a or c, which is 3 times 2. And for b, the order is 3 times 1. So the same things. Okay, we can see here is 1, here is a 3. So we can't do the multiplication. So this also not defined. Okay, now question 4. We have matrix A. Find the possible value of x, y, z such that the matrix A will be symmetric. In order to have a symmetric matrix, AT supposed to equal A. So let's find AT. AT equal negative 1 for x, then y square 1, negative 1, then negative 2, z and 1. Okay, this one supposed to equal A, which is negative 1 for x, y square 1, negative 1, negative 2, z and 1. So let's see. For y square is supposed to equal this element, and this one supposed to equal x, and also z supposed to equal negative 1. Okay, so y square equal 4, which means y equal plus or minus 2, and x equal negative 2, and finally z equal negative 1. Okay, so we finish worksheet 4.1. Now let's solve the last question of worksheet 3.1, which is exercise 3. Okay, so we have here U, V, and W are 3 vectors. Answer each of the following question. Evaluate the magnitude of U and the magnitude of V. So to find out the magnitude of U, we know that is the square root of x square, which is 3, plus y square, which is 25. So this would be the square root of 28. And the magnitude of V is a square root of this a square or x square, which is 4, plus this square, which is 3. So the answer is the square root of 7. Part B. Find the direction angle of vector W. Round your answer to the nearest whole number. So this is vector W. To find out the direction angle, we need to find out the reference angle first, which is tan inverse of y over b. So it would be negative 2 over root 3. Okay. Under the absolute value. So this would be tan inverse of 2 over root 3, or tan inverse of 1.154. Anyway, if you calculate this one, the answer would be 49. and then you round it, the answer would be 49. Okay, so since this vector is located in the quadrant 4, as you can see, this is positive and this is negative, so it's located in quadrant 4. Theta would be 360 minus alpha. So 360 minus 49 is 311. Okay. Find the dot product of U, V. Use the formula of the dot product. It would be A, this is U. Let's write them down. So root 3 minus 5 times root negative 2 root 3. So we will times the first component together. So this would be negative 2 root 3. Then we will add them with the product of the second component, which is negative 5 root 3. Okay, so negative 5 root 3. So since I have here root 3 and root 3, this would be negative 7 root 3. Part D, find the angle between the vector U and the vector V. So to find out the angle between two vectors, we use the formula theta equal cosine inverse of U dot V over the magnitude of U times the magnitude of V. And actually we found out all those values. So U times V is negative 7 root 3. The magnitude of U is root 28, and the magnitude of V is root 7. Okay, of course, this cosine inverse of this value. Okay, and then we can calculate this easily. Okay. Part E, are the vectors U and V orthogonal? Since in order to be orthogonal, the dot product should equal 0. But since U dot V equal negative 7 root 3, which is doesn't equal 0, so the answer would be no. They are not. They are not orthogonal. And this is the reason. Okay, that's all for this week. Thank you very much.